We are magnitude. Let's write it somewhere. This is 5, right? Now E dot this thing, right? So VR minus VP would be minus of E dot this PR vector, right? So this would be how much? This would be minus E and PR and cos of theta, right? Clear? Is it clear?
Yes.
So this would be how much? This is minus and this is E is how much? 2000 and PR is 5 and cos of 37. Right. So what would be cos of 37? It is cos of, this is 5 centimeter, right? So yeah, this is 5 centimeters. So this is 5 by 100. And this is very important, right? So this angle is very special because we know what would be the triangle, right? If this is 37, right? So cos 37 is 4 by 5. And cos is how much? This is base by hypotenuse, right? So this is 5, this is 4, and this is 3. So this is the triangle that you have. Okay. Sine 37 is 3 by 5. So this you have to remember. 3, 4, 5 triangle is this one. Is it clear to you?
Yes, sir.
So cos 37 is 4 by 5 and 5 and 5 cancel. This 2 and this 2 cancels. So you have minus 18 volt. This is VR minus VP. So this is the first question, right? The electric field is going like this and this is VR minus VP that you put. So this is 80 minus 80 volt. The second question is that what is VP minus VR? Right. So what is VP minus VR? So that would be simply minus of VR minus VP. So that would be simply minus of minus 80. So that is 80 volt. Right. And now if the potential R is 600 volt, so we know that VP minus VR, this is 80 volt. And they are saying that on R that is 600 volt. So what is VP? So this is 600 and then this is 80. So VP would be 680 volts. So this is the question that is all about, right? Please note it down, and if you have any doubt, please tell me. Please note this one down. So we have used another approach. We can do this question from IJK formalism as well, right? Because this is electric field has this 37 degree. So either we use this thing, right? The dot product, or we can, yeah, we can use this thing as well. That electric field is 37 degree. So it will have two component, right? It will have this component, right? Which would be how much? What would be this component? Give me one moment. Give me one. Yes. So yeah, what we can write, what would be this part? If this is 37 degree, what would be this part?
99 sub 7,
So this is only
43.
37. Okay, let me just change this question and let me make this diagram a clear one. So yeah, we know that, right? This PR vector or RR or RP, so PR vector, that would be how much? That would be 5 and I hat, right, divided by 100. Is it clear?
Yes.
Right, so this is PR vector, which is RR minus RP. So this thing we have, this thing is there. Now, if you see this diagram, right, this is your x-axis, this is your y-axis, this is your electric field, and this is 37 degree. So this would be how much? What would be this component?
Cos theta.
Yeah, so this would be E cos 37, right? And this
Yes.
would be E sine 37, right? And if I write E vector, so this would be E cos 37 I hat minus E sine 37 j hat, right?
Yes, sir.
And then I can use it in here. So I can use it, this thing would be minus of this whole thing, E cos 37 I hat minus E sine 37 j hat, right? And dot of 5 by 100 I hat. So you see that only I will survive and we'll get the result that we got. E cos 37 and 5 by 100. So similar thing that we got here. So we can use IJK formalism or this formalism, both. So whatever we are comfortable in, right? So please note this question down. And yeah, whenever you want me to scroll down the screen, please tell me. So this is another idea, right? And yeah, this is the solution. Yeah, whenever you want me to scroll down, please tell.
Yeah.
Yeah, so this is the question, right?
Done.
Yeah. And this portion you have also noted. Second and third part. Yeah, noted second and third part.
No.
Yeah, please note this one down. So
Okay.
second and third. Yeah. Okay. So
Yeah.
now work done with electric wheel, with force, all those kinds of things we have done. So now let us let us talk about potential, not this one. Okay. So yeah, this is also potential. So different kinds of potential, right? And not the potential difference, right? We are talking about electric potential. So for point charge, what is the potential? Let's say you have this charge, right? And at this point we are calculating. So let's say this is point P. So Vp and this distance is R. So Vp would be simply KQ by R, right? And let's say if we are talking about multiple charges, so for multiple charges, this would be how much? So that would be simply a superposition principle, right? And then for a dipole, right? Let's say this is a dipole, and yeah, this is A. This is A. We are calculating at this P point. This is theta. So for dipole, potential is how much? Do you remember? Yeah, what is? Oh, so let me
What?
choose another. Yeah, let me just choose another name, A. Right. So for dipole, this is Kp cos theta by r square. Right. This is your R. Right. Is it clear? And again, we have 2 points. So one is this point. One would be this point. This is the equatorial point. And this point, the axial point. Right. So now let's say that if I want to calculate V axial or let's say equatorial. So cos theta would be how much? Theta would be how much? This theta would be how much for equatorial point? 90 degree, right? So theta is 90. So theta is 90 degree. So V equivalent or not equivalent, equatorial, that would be 0. Right. And similarly, V axial, theta is 0 degree. So then V axial would be Kp by r square. Right. So this is the potential for a dipole. And let us do one question to understand this thing, right? So the NCRT problem you guys have already done, so that I won't discuss, right? And yeah, derivation is also not needed. So this is the question. Let me bring this question and okay, that is not the question. The whole question is so this is the question. Can we change the color? Mm. Oh, is this would not be visible, right? Okay, what do I do? Can I change the color? Hmm. Okay, so let me change the page color. So, okay. So now we have this question, right? And there are two dipoles, right? And they have this one and this one are situated on the x-axis. So we have two dipoles, right? A and B. They are situated and its magnitude, its dipole moment is 4aq, right? So it has a dipole PA is 4aq and PB is 2aq. So these are the two dipoles which are dipole moments which are given. Now the distance between these dipole are r. So this distance is r. And find the distance from A where VA equals to VB. So we are finding the distance from A, right? So let's say that we choose this point, right? Let's say we choose this point, and let's say that this point is M. At this point, your VA equals to VB, right? This is given. And let's say that this distance is X. So what would be this distance? MB would be how much? What would be MB? Yes, what would be MB? This distance AM is X. So MB would be R minus X. Right? Total
Yes.
distance is R. Now, what is this point? Is it equatorial or axial point? For A and B dipole, what point is this? Yes.
Action.
So axial. These two are axial points, right? So if we calculate the dipole or the potential at M, so VA would be KPA divided by the distance, which is x square. Right? Clear? And VB would be KPB divided by R minus x square. So they are saying at M, VA equals to VB, right? So this thing KPA divided by x square, that is equal to KPB divided by R minus x whole square. So K and K cancels, right? PA is how much? PA is 4AQ divided by x square, and PB is 2AQ divided by R minus x whole square. So A and A cancels, Q and Q cancels. This is 2. So we can write 2R minus x whole square equals to x square. Right. So if we take the square root in both the sides, taking square root, right? So this would be root 2 R minus x, and this would be plus minus x, right? So we have two conditions. One is that for plus x, this would be root R minus x equals to plus x. So this would be root 2R minus root 2x, and this is x. So root 2R, and this goes the other side. So x plus root 2x, and this would be how much? So root 2R, and this is x1 plus root 2. So then this would be how much? So x would be root 2R divided by 1 plus root 2. This is one solution. For negative x, right? So again, we have root 2R minus x, that is minus x. And this would be how much? So this would be again root 2r minus root 2x and minus x. This goes the other side. So minus x plus root 2x. So now this would become root 2 minus 1. And then this would be how much? So x would be root 2r divided by this root 2 minus 1. So these are the two solutions that we have. And where these 2 points will lie. Right. So let us see that where these 2 points will lie. So this is 1 point. Yeah, let us check only the position. So this is 1.414 r divided by this is 1 plus root 2. So 1 plus 1.4. So this would be 1.4 r and then this is 2.4. Right. So this thing would be right. This thing would be less than r. Right? Is it clear?
Yes, sir.
So where this point will lie? Less than r will lie in between a and b.
Yeah.
Right? And this thing, right? This other thing, which is x equals to 1.4 r divided by 1.4 minus 1. So this is 1.4 r divided by 0.4. So this thing would be greater than r, right? This thing would be greater than r, which means that this point will not lie between a and b. This would be somewhere here, right? So you have 2 points, right, at which VA would be equal to VB. So that would be somewhere M, and the other point would be somewhere here, right? So this would be greater than R point, and this would be less than R point. So both answers are correct. If in the options, both options are given, then you have to write both the options. Clear?
Yes.
Yeah. Yeah. Please note it down. Please note it down. Yeah, whenever you want me to scroll down, please tell me.
Sure.
Yeah, sure. Yeah, whenever you want me to scroll, please tell.
Sure.
Yeah. Okay, so now, so now let us understand the other kinds of potential that we can calculate, right? So the next geometry is the hollow sphere, right? So for hollow sphere, yeah. So potential of a hollow sphere. So there are three regions again. Let's say you have this part is hollow, right? And you have three regions. So one is inside, and then we have this surface, right? And then this outside, right? So at inside, right? P inside, let's say the charge is Q. So V, and let's say that this radius is capital R. And yeah, let's say that outside point is the small, right? So V inside is simply KQ by R, and V surface is KQ by R, and V outside is KQ by small, right? So if you see that on inside, in the inside and on surface, it is constant. It is this constant quantity, but this is variable, right? This is variable. So if we plot the graph of this thing, then what would be the graph? So this is R, which is varying. And at this point, R becomes R, right? And this is your V, right? So at inside, right? In inside, this is the surface region. So at inside, this is the constant KQ by R, this value, right? This is KQ by R. And it is at this point, it is also KQ by R. It is at this point, it is also KQ by R. So it is a constant. So it is constant. And then at surface, after going outside, it starts to vary as 1 over R, right? So this is 1 over R, and this is constant, right? So these are the three regions that we have. Please note it down and we will do some questions. So there is an earthing problem, and there is and there is this other there are other problems as well. Oh, who got disconnected? Yeah, please note it down. Yeah, whenever you have noted, please tell. Noted.
Yeah.
Okay, so now let us find some questions. And yeah, let us understand another thing first. So yeah, we will do questions on this one also, but let us also understand a sphere, right? So potential of not a hollow sphere, but a filled sphere or solid sphere. So potential of a solid right. So now you have a sphere and that is solid. So which color will be? Yeah, let's say, okay, this is also equals. And let's use this color. So this is a solid sphere. And yeah, again, it has three regions, right? One is inside, other one is surface, and then you have outside. So again, this radius is R, and let's say outside point, whatever, let's say this point is outside, this is R. So this is outside. So V inside is KQ by 2RQ, and this is 3R square minus R square. So this is the inside, and this is also written in terms of yeah. So this is R cube, not R square, and this is also written as Q by 8 pi epsilon naught R. And if you take R square inside, so this would be 3 minus R square by R square. So sometimes it is also written like this. Both are equivalent, right? Okay. And V surface is how much? If we put R equals to R, right? If we put R equals to R, so this would be become how much? So this would be Q by 8 pi epsilon naught R. And then this is how much? So this